Hi guys, welcome to this video. I wanted to make a video to do this prelim prep with paper 1 with you based on your submissions for attempts on it. Thank you very much to the 2 people that did submit. Good luck to you too, and let's get going immediately so that we don't waste time. So our first question was to solve for x. Here is the question, and guys, remember, when we solve for x in a quadratic expression, that means there is one x with a square. We factorize and then solve. Come on. We factorize and then solve. Each factor we make equal to 0. So I look quickly here. One submission is exactly what you did. You factorized, but then you only took one of the answers and made it equal to 0. Remember, there should be 2 answers because there's an x square. The square will tell me there's 2 answers. If it was x cubed, a 3, there should have been 3 answers. When it's x to the power of 4, there should be 4 answers. So there should be 2 answers. In this case, one is minus 8 as you did. But in this case, let me just go to the other student. Other student submission here. There we go, it's a little bit small. Here you can see she did it exactly right. There's an x is equal to 0 and there's an x is equal to negative 8. Well done. Next question. And this question is a trick question, as you can see. But what I want you guys to notice in this question is that, and this is really what you have to do, and it's only possible to do if you are focusing. Notice that there's an x squared minus 5 here, and there's an x squared minus 5 here. And other than that, this seems to be quite a lot of work. I have to multiply this out, and this is what both of you did. Both of you went and multiplied out this question, multiplied it out, and look at all the work you did. And I'm not sure if this is the correct answer, but this looks very good overall. There's 2 answers, and then there's this third one that you didn't continue. Yes, you did. You did continue to get the answer for that one. Well done. And then on here, same attempt. You did that, and then up to here, I don't know what you did from this step. Okay, student 1, I don't know what you did from here to there. You get 12x squared. No, I have no idea what you did from this step to that step. This one tells us we have to have 4 answers, and student 2, you has the 4 answers. Look, she's got 1 here, 1 here, and is there another one? Yes, 1, 2, 3, 4. Okay, but let me do that question for you and show you how easy it actually was. First of all, notice that there is a repeat of something, and when there's a repeat of something, it's usually just easier to replace that with a value. So let me just see what is the okay, so I'm going to make this equal to k. Call it k substitution. K plus 2 squared minus k is equal to 8. So that's what I'm going to do. So the question is x squared minus 5x plus 2. This whole thing is squared. Minus, and then k is equal to 8. Minus k is equal to, sorry, not k, but what I'm going to call k. X squared minus 5x is equal to 8. Okay, so now notice how easy it becomes when I just make this a k plus 2. This thing is squared minus x k, because I'm making this whole thing equal to k is equal to 8. So you could just say for your examiner, let x squared minus 5x equal to k. That just helps us to know what the heck are you doing, but most examiners will know. And then this simplifies very easy to k squared plus 4k plus 2 minus k is equal to 8, and then we get k squared minus 3k minus plus 3k minus 6 is equal to 0. Oh, sorry, I made a mistake. That is 4. Okay, so this must be k minus 4. There we go. And the reason why I knew that was wrong is because this thing can't make brackets easily. And if it can't make brackets easily, it's probably wrong. Okay, and I just quickly looked and saw I really don't know what the memo answer is. And so this is k plus 4 k minus 1 is equal to 0, and then so k is equal to negative 4, or I don't even have to do that. I can just say, okay, so that means that now I can substitute back x squared minus 5x plus 4. You see, I just replaced k with or x squared minus 5x minus 1 is equal to 0. And so we've got x, this one can factorize further, x plus 4x minus 1, plus 1, no, sorry, both of them are negative. Shucks, I haven't factorized in such a long time. X minus 4, x minus 1, and then this one can't factorize. I'll have to use my quadratic formula for this one. And so x is equal to 4, or x is equal to 1, or, and then I'll use my quadratic formula to solve that. X squared minus 5x minus 1 is equal to 0. And so if I just go and look one of the student responses, I think that's exactly what she did here. Look, she gets exactly the same answer, but look at all the work she had to do. She first had to multiply out, so that's just way too much. You get the same answers. Well done. That is a lot of work. 6 marks, so that's still worth it, but it could have done much easier with k substitution. Okay, let's look at the next question. Student, I'm not sure, you're definitely not getting the right answer, but up to this point you were on the right track. Now you just had to do polynomial long division to first find roots. So you find one value, and I think that's maybe what the student did, is she found one value that could be a factor 1. To be honest, I have no idea how she did it, but it's still good. You can use your calculator. Some calculators can do it. Next question. Go back there. Next question. Oh, this question. Okay, what is this question all about? Well, guys, remember that when we're trying to solve an exponential equation, we know when we have to work with a polynomial, we have to factorize. With an exponential equation, that means our unknowns in the numerator, we have to try and solve the base exponent. And the base exponent in this case is 2 to the power x. So what I mean by solving it means I want to get it by itself. So if I want to get that by itself, I'll say 2x. So let's just see what the two responses is. Okay, so here, dividing both sides with a 2 is good. No, see, here's the problem. You can't, when two bases are being added together, you can't add their exponents. The law of exponents says when I multiply bases, I add exponents. So this is totally wrong. Please don't do that. Okay. Next student, what did you do? Nothing. Okay, I'll show you then how to do it. Okay, so we have, in this case, we have 2 times 2x plus 2, and then what was that? 2 to the power 2 minus x is equal to 17. To the power 2 minus x is equal to 17. Now guys, this is very important. You will get a question like this. I haven't seen the prelim paper, but you will get some sort of solving exponential equation, and they always work the same. Okay, first of all, what you'll have to do here is say, just deal with this part first, because I want to get 2 to the power of x by itself, but here's another 2 to the power of x coming out here. Let's see if we just separate the bases, because what I want to do usually is factorize, but I get 2 to the power of 2, and then what does minus x means? It means it used to be divided by 2 to the power x. That's how I got 2 to the power minus x, 2 minus x, because I subtracted exponents. So this is what it used to be, is equal to, now this was good. What the one student did is to divide both sides with 2. That's fine. And there's this common misconception, make bases the same on both sides. Yeah, that's true, but the whole point is still to just get the only reason why I want to make bases the same, and now you see there's this repetition. What did I say when I said we see repetition? We use k substitution. It just makes life so much easier. So I say k plus 2 to the power 2 divided by k is equal to 17 over 2. And now I just go ahead and solve for k. What do I do when I have a fraction in an equation? I multiply with the denominator. So I get k squared plus, when I multiply this with k, it just becomes 2 squared is equal to 17 divided by 2 is 17 over 2k. Okay, and I probably want to deal with this 2 as well, so probably just multiply everything with 2 again. So this might not have been the ideal thing to do, dividing both sides with a 2, but let's see. So I can have on here k squared, let's say 2k squared, and then this will become 17 when I multiply with 2, so minus 17k plus, and this is 2 to the power of 2, that's 4 times 2 is 8, is equal to 0. And so now I'm going to factorize this into 2 brackets. This is definitely 2k, that's definitely k. Why aren't I replacing it back yet? Because can you imagine how difficult this thing is going to be when I put a 2 to the power of x in here? Now I'll go until this thing is as simple as it can possibly be, then only will I put back my k. So remember I said let k equal to 2 to the power of x. So before I do that, this thing must look simpler. Okay, so what possibly can this one be? Can we make it a, I really don't know, can we make it a 4 and a 2? Let's see. 4 and 4 will give me 8, so no. Probably because I have to get to 17, it must be quite big values, and that's an 8. That makes sense. So say 2 times 8 is 16, and then this must be 1, and both of them must be negative. There we go. It's my 2 answers. Minus 1 times k is minus k, and minus 1 times 8 is minus 6. Minus 2 times 8 is minus 16. That gives me minus 17. Perfect. So in other words, I have that 2k is equal to 1, and I have that k is equal to 8. Excellent. This is a good time. Maybe I can even say k is equal to a half, or k is equal to 8. And now is a good time to replace back. 2 to the power of x is equal to a half, or 2 to the power of x is equal to 8. And now it's actually very easy, because what exponent must I give 2 so that my answer is a half. Please read it like that. I don't know, some people do weird things with this. No, what exponent must I give k? A negative 1. So x must be negative 1, because 2 to the power of negative 1 is a half. What exponent must I give 2 so that my answer is 8? I must give x is equal to 3. Okay, let's look at the next question. Okay, here is a quadratic inequality. Oh, and I dread looking at answers. I really hope they did it right, because these, you guys just lose it. It's so simple, but they just lose it. Let's see. Okay. Yeah, see, this is what I mean. I don't get it. It's not an equation. So up to this point, you're doing it brilliantly, and then all of a sudden you make it an equation. Guys, it's not an equation, and it's definitely going to be something in your exam. So please, please get this. Up to this point, you did it perfectly. Let's see if student 2 did it correct. Okay, she gets to that point. Is that the same factors? You get -4 and 2. Yeah, see, this student is on the right track, but it's not equal to 0. This wasn't 0. You get that right. Okay, it's smaller than equal. Well, almost. That should be a smaller than equal to. But yeah, so again, you see how strange things are happening here. So yes, let's follow the student is correct. Multiply it out first. That's actually a 6. The other student might have had it right if she saw it was a 6. That's actually a 6. And then we simplify it until we get there. Then we factorize it perfect. But what do we do from here? Okay. Please keep this in mind, guys. It will be in your exam. So we have x -4 and x +1. So if I have x -4 and x +1 smaller or equal to 0, then I draw a rough parabola. Remember, this is actually a parabola, and these are the two x-intercepts. Now, just a rough one, and I see that the smaller one is this intercept, and the bigger one, that one. So this one is -1, and that one is 4. Now my graph is saying I'm using everything less than 0. So less than 0 is the graph below the ground, and greater than 0 is the graph above the ground. We see that the graph below the ground is this part of the graph. It's the graph in between -1 and 4, and that's why I say x is in between -1 and 4. The graph says include, or the question asks including 0, and these are the points including 0, so I must include them in my answer. It's that simple, but it's not as silly as just making the two answers equal. Okay. Let's see, here is, this, guys, was actually a very stupid question. Even Lucy's moderator, when he looked at this, he was not happy with that question. So I'm going to skip it. They say determine the values of a and b if the roots are 3 and 1/2. So in my opinion, the value of a and b should actually be very easy. B, if the roots, so obviously x plus b is then 3. So b must be 3. Okay? -3 actually. So if b is -3, then a must be, so let me write it like that. I don't know if that's what you guys did. Let's see. No, this student didn't do anything. This student didn't do anything. But I mean, that's, look how easy it actually is. I mean, these are the two roots, a and b. So you know that x plus b is the simpler one, so he must be the simpler root. So in other words, if ax plus b and x plus b is equal to 0, then they tell me the two roots are 3 and -1/2. That means that x plus b equal to 0, so x is equal to negative b. So that must be this one. So if negative b is equal to 3, then b is equal to negative 3. So now I have that ax minus b minus 3 is equal to 0. And then, so in other words, x is equal to 3 over a when I solve it. And 3 over a must be equal to this other answer, that one, minus 1 over 2. And then I just solve for a. Now, basically it just comes down to it. 3 divided by what will give you negative a half? Well, 6. Negative 6. So a is equal to negative 6. So, looking at it again, it's not such an ugly question, but yeah, those are that would be my response. But there were some problem with it. I can't remember exactly what it was, but I'm not going to go into that. The next question, show without the use of a calculator that thing. So let's just quickly look at student 2 didn't attempt it, student 1 attempted it, and did a pretty good job of it, I must say. So up to this point here, she's doing it correct. What she just did is just, first of all, I think here she just multiplied both things with a square root of 2. So if you multiply this with a square root 2 and that with a square root 2, then at the bottom we get a square root 2 times square root 2 is 2, and the 2 cancels with the 4. So that's where the 2 comes from, and then the square root 2 comes from multiplying top and bottom. Okay, so up to this point, that's what she gets. Then in the next step, what she did is to add the two fractions. And so to make this one a fraction with that, we multiply the top and bottom with that. And up to this point, she did remarkably well. Okay, so 2 minus, and this is what we get. I don't know what happened to her denominator here. I don't know what happened to her, but up to this point, you did brilliant. Let's just go on from there, because then you lose it. All you had to do is multiply it out, and you would have seen that, well, let me just see. You're doing your numerator, you multiply. I don't know what's happening here, where this extra plus 1 comes from. Where does this plus 1 come from? And why is there all of a sudden a bracket here? This was good. 2 minus 2 square root 2, 1 plus square root 2. So let's go on from there. Running out of space. Okay. 2 minus 2 square root 2, 1 plus square root 2. That was your numerator, and your denominator was 1 plus square root 2. And now let's just simplify. We just multiply this in. So we get 2 minus 2 square root 2 plus, now when this multiplies that, the square root 2 and the square root 2 cancel, so that it's just 2 times 2 is plus 4. Okay, and then we get, which is slightly minus 4. Minus 4. Why minus? Because there's a negative in front. Minus 4, and so and then in my denominator I get 1 plus square root 2. So we're not doing too badly. Then in the denominator, we if we continue with this, 2 minus 2 is minus 2 minus 2 square root 2 over 1 plus square root 2. Now, the excellent thing that it seemed you were trying to do is you seemed to wanted to cancel common factors because you factorized. but you didn't simplify correctly, so your factorizing would have been perfect. At this point, all I do is I take out a -2 because I want this expression. The only thing I can't do anything to the bottom, so if I can just in the top get this 1 plus square root 2, I'm going to be sorted. So I take out a -2 as a common factor. I'm left here with a 1. I'm left there with a 1. So plus square root 2, and that can cancel with my 1 plus square root 2. And that's where I then get my final answer that they asked to show that that expression is equal to -2. Okay, that's question 1. Next video, question 2.